planning policy framework, as a lot of planning policy in this country in recent years has been slimmed down and simplified. There used to be a lot more technical guidance than there is now. There is limited discussion of land quality, contaminated land and stability within the framework. What there is summarised here. So the development should not be put at an unacceptable risk or adversely affected by soil, air, water, or noise pollution or land instability. And then secondly, so that's making sure that people and the places are adequately protected, but then it's got a slightly higher aim as well, saying that where possible, these developments should help to improve local environmental conditions. And it goes on to say that the site needs to be suitable for its proposed use, which is difficult because there is no real good scientific understanding or definition of what suitable for use means. It's a nice generic term that was written so that it's understandable to everybody, which is good, but it's a little bit hard to define, unfortunately. So it does lead to some vagaries within the assessment process. And any risks arising from land instability and contamination. So it then goes on to say that as a minimum, so as a benchmark, the land should not be capable of being determined as contaminated land under Part 2A of the Environmental Protection Act. So within the UK, we do have an official legal definition of contaminated land, so almost like capital letters, because we gave birth to the Industrial Revolution in this country, and a lot of the country has been contaminated to a degree. Then this is very pragmatic legislation designed to identify the worst sites, those posing the greatest risk. It wouldn't be much use if it captured most of the previously developed land in the UK. It's designed really just to target the worst, but I'll come on to that. And 179 says that where the site is affected by contamination or land stability issues, the responsibility will always rest with the developer and or the landowner. So whatever planning permissions, whatever regulatory approvals a developer may obtain through the planning process, that responsibility always resides with them. And it does require that these assessments are undertaken by a competent person. And this is, again, quite difficult to be precise about. There is actually a definition within the planning policy. So there, I've just repeated the competent person, what it is. In effect, you're looking for somebody with relevant qualifications and sufficient experience of pollution or land instability, depending on what the issue is. Because we're talking about ground conditions, it can often be both. And I'm speaking to somebody who is a contamination specialist. Within my team, I have a lot of geotechnical engineers and geotechnical capability, but I don't count myself amongst them. So when you're looking for this competent person, actually, it's often more useful to think of a competent team, because you will need a group of land quality specialists who can tackle all of these issues. And you need a diverse range of skills, whether it's geology, chemistry, biology, engineering. Normally you will get these professional qualifications only via a group of people. There is the National Quality Mark scheme, which has been developed in the last few years, where a client can ask for a report to be produced by a suitably qualified person. This has limited uptake at present, but it does have the potential to grow, and you will see some documents issued by the Environment Agency and others refer to this, where you can use it. It doesn't mean that these reports won't have the same level of regulatory scrutiny as they go through planning, but it's a signpost for people who are unsure of where to go for expert advice, that they might want to look that up as a starting point. And the NQMS, as it's referred to, there's a website and a list of people who've achieved this quality mark and are suitably qualified people. So this is one thing that I think we'll keep coming back to, that the information sought should be proportionate to the decision. So there's no kind of one size fits all in terms of what type of studies and work needs to be undertaken prior to planning or to support planning, or even to discharge planning conditions once planning has been granted. However, and this is where the planning practice guidance is not necessarily the most consistent the way it's written in terms of land quality. When it talks about outline planning and what information needs to be provided to support outline planning permission, then the planning authority needs to bear in mind, has enough information been submitted to demonstrate that any necessary remediation would be viable or practicable. And as just one example of where this is not necessarily the most helpful wording, some of the most substantial costs that may arise from this subject are actually down to instability, but there's no wording as to whether it needs to be viable from a stability point of view. It's just talking about contamination remediation. So, but it is referred to there, and I have seen it where planning officers have asked for evidence that the scheme will be viable with remediation costs and requirements taken into account. So on to contamination, and this is where Sinead was going through. So just because a site has contamination within or beneath it does not mean it's contaminated. In our UK definition, we have to demonstrate that a receptor is actually posed a risk from this contamination via some form of pathway. And there are specific receptors that are required to be considered. So human health on and off-site, controlled waters, surface water and groundwater. And then there are ecological receptors, albeit these are only statutorily designated ecological receptors. So we're talking about particular ecological SSSIs, special areas of conservation, special protection areas, and Ramsar sites, which are wetlands. Those actually do up to quite a large number of specific sites in the UK, but it's those, if they are directly threatened by contamination from a site, they need specific assessment. And where does planning fit into contamination assessment within the UK? Well, I've already talked about Part 2A. This is apologies, it might look slightly complicated, this slide, but it's aiming to summarise the major parts of contaminated land legislation in one nice slide. So here we go from the bottom up. This is really the least amount of remediation you would need to achieve to meet the appropriate conditions. So it's the most pragmatic legislation, Part 2A. It's designed for local authorities, and they are the ones who are required to do this work and determine sites, for them to look at their areas and proactively search for contaminated land. So it's really designed to capture those sites that won't be dealt with through the planning process. And this is an area that has been underfunded for the last 5+ years, and there's not an awful lot of proactive investigation going on at the moment because the local authorities do have a lot of other pressing needs and priorities for their funds. So most of the remediation, in fact, probably about 90% of remediation that goes on in this country is actually related to planning directly. So this is for new developments, and within the technical guidance that is provided relating to planning, some of this has kind of disappeared from the .gov website, as again they've removed and simplified the guidance. But as well as reference to the sites being suitable for the proposed use, there's also reference to what is called a minimal risk level, which again, us scientists can argue over till the cows come home, but there is that in there, that it's designed to be, we're supposed to have higher ambitions than Part 2A. We want to make sites that are proposed for new uses to be better than they have in the past. So that's the aim. Then the top two are really just for regulating industrial and current potentially contaminated land uses, and there's actually a very high level of contamination management required, where there's no deterioration effectively allowed under those. So if you have an industrial permit, then they have to demonstrate that those activities are not contaminating the ground. So that's where planning fits within the UK contaminated land hierarchy. So the legal definition, as I've mentioned, it's one way of looking at this is you have to positively prove that significant harm is being caused, or there's a possibility of significant harm being caused. So it's not just that there's slight contamination, there might be a problem. It's got to be far more definitive than that. A way of looking at it is that the site is very much innocent until the scientific evidence proves that it's guilty. So you need that there's quite a heavy burden of proof required, and not an awful lot of sites pass that threshold. So on to, and that forms the baseline. So as we say, that as a minimum under planning, no site should be capable of being determined as contaminated land. And one of the case studies will come back to this where it's not quite worked out like that. So within the policy framework, there is a flowchart to show what is needed, and some of the writing there is a little bit small, but hopefully you can read that. This is a guide for what information might be required when through the planning process. So initially, there's a question at the top, and this is really, I mean, this is guidance for everybody, but could be viewed by being read by the planning officer. But at that very top level, you can, in theory, proceed to a decision, assuming or concluding that the contamination risk is very low without any form of depth study at all. It may be that there's sufficient local knowledge that the site has always been undeveloped. It may be a single dwelling that the authority knows terribly well. It would be very rare for that to be approved without any information whatsoever. Most commonly, you would go down to the second tier, where you might be aware of this as a desk study or a phase one, but the terminology for planning is a preliminary risk assessment. So review of environmental databases, historical maps, site inspection, assessing what is the risk of contamination being present on the site from historical site uses, the current recent land use and surrounding land uses. And often that is what is then submitted with a planning application. And then if that is the case, as you'll see to the right, once and if permission is granted, then often you'll have conditioned the detailed assessments. So the site investigation, where boreholes and trial pits are excavated, where there's laboratory analysis to actually say, is this site contaminated or not, basically, and that is through the detailed risk assessment phase if contamination is actually recorded. But there's a key kind of distinction halfway down, really, as to whether that preliminary risk assessment is going to be sufficient to submit with planning, or whether there needs to be site investigation information submitted to support that planning application. Putting ourselves in the mindset of the developer, it may be that they've not purchased this land yet or purchased this site, might be a significant investment decision, and a desk study will normally cost £1,000 to £2,000, that kind of range of things, whereas a site investigation will quite often, you'll put a naught on the end. So once you're talking about drilling boreholes, you're possibly talking £10,000, £20,000 or more. So the developer may be unwilling or reluctant to undertake site investigation until planning permission has been granted, because that means that the return on their investment is more confident. It may mean that they've purchased the site, they're much more confident to invest in the development going ahead. Of course, as planning officers, that is irrelevant, to be fair, and there is specific guidance on whether that investigation information should be provided before or after. And I think this might be on the next slide. Here we go. So in terms of use of conditions, so Circular 1195, which is still referred to in the government guidance on contamination. So if it is known or strongly suspected that a site is contaminated, then an investigation will normally be required before the application can be determined. So again, it's not necessarily the most scientific language there, but hopefully that's a helpful aid memoir for considering whether that ground investigation should support a planning application or if it can follow on afterwards. And then 75 is the converse, where if there's only a suspicion that the site might be contaminated, or where there's only slight contamination, then permission may be granted subject to those conditions. So that is a means of determining whether that investigation needs to be provided in support of an application or if it can be conditioned and follow on afterwards. So here's just a brief run through of what these things include. So as I've already discussed, a preliminary risk assessment includes a summary of historical land use, environmental databases, the geology, ground conditions, etc. And normally takes a few weeks, and like I say, is at most a few £1,000s depending on the size of the site. So includes all of that information in a decent study together with a site inspection. Whereas ground investigation, as you can see, is a lot more intrusive in all senses of the word, a lot more disruption to the site, and will involve a variety of techniques depending on what depths needs to be drilled to, where samples need to be obtained from, etc. The ground investigation will be supported by laboratory analysis of definitely soils and frequently groundwater, potentially surface water as well, and ground gas monitoring will normally be required to assess risks associated with ground gases, either to the future users of the site or surrounding land uses. So there will normally be an initial fairly generic screen of laboratory results. So just an example on this, you can see in that table on the right, there's some arsenic results. Within the UK, there have been developed a range of generic acceptance criteria, which in this case, for arsenic for a residential end use, the acceptance criteria is 37 milligrams per kilogram. To cut a long story short, that's not an absolute number. It just means that if you have concentrations above that level, it needs further assessment. It doesn't necessarily mean that that is going to pose an unacceptable risk. It just means you need to do more detailed assessment on it. So, and at that stage, you then look to do detailed risk assessments where you move beyond those generic values and use some more sophisticated scientific tools and computer models to generate actual site-specific targets. And then if those are exceeded, then we are looking at undertaking some proper in-ground remediation. So this whole process, in an ideal world, you will be, or the consultant will be liaising with the local authority and or environment agency as they go. So the environment agency for contaminated land will typically be consulted via the local authority. They may determine, they'll normally have a quick look at the sensitivity of the site with respect to control waters. So is it near a surface water course? Is it on a protected aquifer? Is it near a groundwater abstraction? If they determine it's not particularly sensitive, they will effectively say thank you, but no thank you. We're not particularly interested, please, and refer back to the contaminant land officer, who will then provide the appropriate review and whether the risk assessments are acceptable or not. If the site is in a sensitive location or the EA are particularly interested, they will provide specific comment. So that's not always the case. It used to be far more frequently, but their resources have been reduced, certainly since the noughties, and their priorities have changed somewhat. So as necessary, a remediation strategy and verification plan will be required. And this is quite often the most common forms of remediation are actually relatively straightforward. So for most residential developments, the key is to be, if a risk has been identified, the key is to block any pathways rather than necessarily remove the contamination at source. So that previous example where there was slightly elevated arsenic, that is actually very common in this country. then the most common solution is actually to provide a clean soil cover layer. And so the remediation strategy will need to state how thick that needs to be, the quality of that topsoil and subsoil that is normally imported to the site, and then how that is to be verified to provide the reassurance to the regulators and all of the stakeholders that that has been implemented properly. So that is most common. The second most common is probably gas protection measures, which again does not involve removing the source, but typically is protecting future buildings, future dwellings by incorporating protection measures within the actual building fabric itself. So this is the typical type of remediation that takes place. There's other things that can happen. Often there'll be localized hotspots of contamination or associated with tanks and so forth that need to be dealt with. And it goes on to some potentially very complicated sites, depending on what that site history has been. So just quickly on to a case study for a site that didn't quite go right. And to be fair, this one did happen in the 1980s before the current guidance. This is just about the most contaminated site in the UK. So I appreciate it doesn't really look like it, but I will come on to that. This is how it looked in the 1940s, I believe. It was a fairly small chemical works in a village in Hertfordshire. So, and it was operated by Steatley Chemicals, who manufactured potassium bromide. And then Crest acquired the site in 1983 when the site shut down. And in 1983, Crest demolished the buildings and removed the slabs. And the process of going through planning and developing took a few years. So in 1987, planning permission was granted for 66 properties. And remediation that was deemed to be acceptable at the time was undertaken, and it was signed off and approved by the local authority. Since 2000, in the wider area, there has been groundwater testing undertaken in the chalk aquifer, and found this to be unacceptably contaminated with bromate, which a lot of work by the Environment Agency identified this site operated by Steatley Chemicals as the source. So a remediation notice was served. Redland and Crest, so the original polluter and the developer appealed. It went through various appeals. It went on for years, to be honest, and it was rejected in the High Court. And they have been required jointly to pay for the remediation costs, which have been over 20 million. And the question is why? Basically, this is ongoing for a long time, and this is the size of the problem. So effectively what happened was shallow remediation was undertaken, and the residents at the site are at no risk whatsoever. They were quite satisfactorily protected. However, the residual contamination at depth has been continuing to leach into the chalk aquifer and has now migrated over a distance of 30 kilometres. So this is the Lee Valley in East Hertfordshire, and the contamination's gone an awful long way. It is only being controlled by very vigorous groundwater pumping and disposal. An awful lot of groundwater is having to be discharged that used to be drinking water, and it's not yet in a steady state, and that problem is ongoing. So one of the reasons why this is useful is that suitable for use in this whole legal judgment, it was decided by the judge that this needs to apply to water polluted back on the land. So if there is still a risk to the wider environment, even though it might be suitable for use at the surface, it is not suitable for use for a planning perspective. So that is now a legal judgment. So again, even if the work is approved at the time, then it can still remain a liability for the developer. So this is another one that has gone through planning. This is Spodden Valley. This is the former Turner Renewal site in Rochdale. So that's it there on the top right hand side. So disused factory. Bottom right hand side is the woods, where that white stuff is actually asbestos fibres at the surface. So the owner and the house builder jointly submitted outline application in 2004 for residential development, and after a lengthy series of investigations, they submitted various reports in support of this application. Over time, it became incredibly controversial locally. There was a very effective local action group, got an awful lot of publicity. The issue was raised in Parliament on several occasions because it became so controversial. Effectively, the early reports, without wanting to say too much, they did appear to downplay the extent of contamination, particularly with respect to asbestos in soils. And the end result was that the applicant never was able to submit sufficient information or reassurance that the site could be safely developed. And this is a direct quote from the planning decision in 2011, so it took a very long time. But this was the decision notice. So the applicant has failed to demonstrate whether the whole site can be safely and adequately remediated to support its safe development and future occupation. And the site is really a site of two halves. You've got the factory in the top half, which in theory can be developed reasonably in a reasonably straightforward manner. The woodland is in a steep-sided dell with a river flowing through the middle, and woodland has grown up through the former tip. That is much more difficult to remediate technically and will always be a challenge. And the owner has tried since then to, from a planning perspective, detach the two areas and just obtain planning permission for the factory area, which is the flat-lying area, and let's say is more straightforward. The local authority has refused for that to be allowed, and basically does not want to allow creation of what would be an orphan site, which has substantial difficulties, and enable the wider area to be redeveloped. So I'm not a planning specialist, so I don't know the technicalities of that, but that's effectively where the site currently sits, and it is therefore still derelict. There have been some further investigations that have taken place, but it looks like that it will require substantial funding support to support a development in the future. It's not something that looks economically viable without intervention. However, just coming back to Part 2A and the legal definition of contaminated land, this is not a Part 2A site. You might find yourself surprised when you can see loose asbestos at the surface in the woods. The simple fact is that the site is fenced off. So humans are prevented from entering the site, therefore there is no receptor on site that can be exposed to that asbestos, or at least that is the principle anyway. So it is not a Part 2A site, despite it being very contaminated. So that's just a reminder of how important the conceptual site model is, and that presence of not just a source, but a pathway to your receptor. So those are two examples where things have not turned out brilliantly for the developer. Here is one where we've been working on for a long period of time. This is actually one of Sinead's examples, so apologies, I don't know the details particularly, but we have been working for the London Borough of Barking and Dagenham for a long period of time to support the redevelopment of a huge area of formerly industrial land and quite contaminated land. And that has been successfully undertaken through a number of years. And just going back to that, it does rely on a good level of initial information, both desk study and site investigation, particularly on a site like this, which had a lot of heavy industrial usage, to provide confidence to the regulators, and then undertaking more detailed stage investigations as individual plots are taken forward for development. So I realise that we are probably running a bit short of time, so I'll try and quickly run through some further aspects of ground risk. So just to be aware of standard planning conditions, there have been a number developed, but as a consultant, where we don't often particularly get involved, just a few tips really to try and make sure that they are both as site specific as possible and can be implementable. So make sure if there are pre-commencement conditions that they can actually be achieved via pre-commencement. So a classic one is requiring a ground investigation pre-commencement. Well, if the site is completely occupied by buildings, then you need to be allowed to undertake that demolition before you do the proper investigation. So it might just be notwithstanding demolition, pre-commencement or whatever, but that kind of thing. Preoccupation is a very common one. So going back to a residential development site where you have a requirement for clean cover in gardens, then that is normally the very last thing a developer does. If it's a scheme for, say, 500 houses, then they will have finished the first houses months or even years before the last houses are occupied, and that whole verification preoccupation condition might be under one planning condition. So between the council and the developer, ideally you would find a way of staging that condition so that occupations can be allowed whilst the planning authority still has control over those final plots being validated. So just bear that in mind. So there is a need often to satisfy both sets of regulators, and it can be a bit of a long chain of communication at times, particularly where the Environment Agency is involved. We have to be very proactive as consultants to make sure that where we think there is a potential risk to surface waters or groundwaters, that the Environment Agency are involved, or at least ask the question. That can be a bit tricky if going through planning consultants, then the planning authority, then the Contaminant Land Officer in the local authority, and finally the EA. So that can be a bit tricky. So there are, yeah, definitely benefits in understanding how those conditions can be discharged, and so that pre-planning engagement can be very important. So this is what we've already commented on. So onto ground instability, a nice shot there of a Cornish tin mine, which that opened up in somebody's back garden a few years ago. That photograph is taken via a drone. You'll be pleased to hear. So ground instability comes in a number of guises in the UK. Some are very common and familiar, some possibly less so. Coal mining is one that affects specific areas. Brine subsidence and former salt mining also specific areas. Solution features will relate to carbonaceous deposits, so limestones and chalk and so forth, and particular areas. Slope stability will relate to particular topography local to a site or even on site, so that can be very site specific, as can compressibility. So that might be deposits of peat, or there might be clay deposits, particularly in the southeast of England, that have very high volume change potential depending on moisture content. So there's some clays, particularly in the southeast of England, that can be affected by that. So similarly, the planning policy framework provides a flowchart for land instability and can refer to that there. But again, there's a process of, if there's a risk of instability identified, and a good preliminary risk assessment should ideally cover off both instability risks as well as contamination risks, but do check the scope of that report to make sure that has been covered. Then they should be identified. Local authorities might have very good knowledge of their particular patch as to what issues they come across and need to deal with. But again, it's a commensurate level of information to the risk. So making sure that either all these issues are discounted or addressed appropriately. And there's a reason why this is particularly important. So coal mining areas, again, it's particularly familiar, but does cover quite a lot of the area. So that map on the right-hand side shows the areas that are affected, but it's actually those black areas that are the most high-risk areas. Those are mine shafts. But there's a lot of the country that is potentially affected by coal mining. This is a fairly typical coal mining planning condition. So the Coal Authority is a statutory consultee for coal mining areas, and you can see on their website they have a very helpful tool. But where there's a high risk area, by their definition, then there needs to be a coal mining risk assessment, or a CMRA, to be supported, to be produced in support of planning permission. And that may be desk-based initially, but may require intrusive investigation to be done. So as an example of the kind of issues you come across with coal mining, this is a very innocent looking field near Barnsley, but it was a former open cast. This isn't the actual open cast itself, but the open cast mine in this field was about 20 meters deep. Can be quite hard to imagine. This was in the 1990s, so it's been restored fairly recently. And as you can imagine, what you can see there is a partially backfilled open cast in the near ground. So you've got loose fill placed against what is termed as the high wall, so the old wall of the quarry. And to the left of that high wall, if you build a house there, it's straight onto solid rock. You've got no stability issues whatsoever. On the right-hand side, you have some stability issues. Normally you'd be piling into the bedrock below the base of the open cast. The real risk area, however, is the transition. So in the past, there's been schemes where this hasn't been spotted and houses have been built over the actual high wall itself. And what happens is the house foundation kind of rotates and tilts and cracks in two, in effect, in places. Numerous houses over the years have had to be demolished because that has not been spotted. And what you have is you have a no build zone. So this, we've been working with the developer on this site to identify and avoid the high wall. So that orange shaded area in the middle of the site, they have completely avoided that former high wall to ensure that those risks are avoided. Now, if that master planning exercise had been done before this investigation, before this work had been done, then potentially they would have had to rip up the master plan and start it again. So it's very important where there's a site like with an open cast that this work is done before the planning application is made, because that master plan that may be approved could be undeliverable, and also it could be unviable if you start having to effectively delete plots from a master plan because they're over a high wall. Then how many houses do you have to remove before the scheme becomes completely unviable for the developer? So it's very important that's taken into account. Coal mine, so former mine entries is a similar one. So this is a series of potential mine entries circled in red on an existing master plan that's not taking it into account. And so, for example, the one in the southern centre of the site there, there's actually a plot over there. And because it's not taken into account the mine shafts, effectively houses cannot be built over mine shafts, even when they're treated and capped, because the residual risk is considered too high by the coal authority. So if this developer had proceeded with that master plan and then found or attempted to locate these shafts, there's potentially a good number of houses there that could not be built. And again, if this developer had to remove half a dozen plots from that development, does it suddenly become unviable? So make sure the master plan is developed with the location of mine shafts in mind. And this is one that has been done. So this is the way to do it. So this is a site in Stoke-on-Trent that had a number of shafts, and the architect and the developer have moved the plots out of the way to avoid the potential zone of influence of the former shafts, so that wherever they're located, they know they can confidently still go and build these houses. So that's a way of managing the risk early on and making sure that they don't obtain effectively worthless planning permission. Because remember, just moving one or two plots around to try and avoid mine shafts means you have to start again with your planning application. So the time and cost associated with that is not inconsiderable. Just to give you an idea of how big some of these features can be. So this is a recent housing development where a shaft is being treated, and it just shows the kind of area that they can take up. So if it's not taken into account at master planning stage, it can be a really significant constraint. So I will move on through here to salt mining. So very specific to my neck of the woods, South Manchester, Cheshire is probably the main area where brine is a particular risk. So the plan on the right is showing the brine consultation areas where there are particularly known risks. So areas around Winsford, around Crewe and Northwich are particularly known as issues. And there can be, so there's some very famous photographs of Northwich which subsided on a huge scale in the 19th century, when all of the underground interconnected mines became flooded. Somebody accidentally diverted a surface watercourse into a mine, and it started, basically it turned into an underground river that started dissolving the entire underground salt network. And that kind of thing happened literally overnight in some cases. Again, in the Cheshire area, there will be specific conditions if necessary, and there's the Cheshire Brine Subsidence Compensation Board, which is a bit of a mouthful. They are part of the Coal Authority now, very similar to a coal area. There needs to be a specific process gone through, consultation undertaken with the board, and there can be broad subsidence because of salt dissolution at depth, but also there are brine shafts and brine wells which have to be treated very similar to a coal mine shaft, and again that can affect the master plan, so that needs to be considered too. There's other types of dissolution that take place. So this is gypsum, which occurs through a strip of land through the East Midlands and parts of Yorkshire, and this has caused some very recent substances as well. This is some fairly recent substances that's occurred on existing housing. It's quite a well-known issue in the area, and particularly around Ripon. A lot of work is being done on this particular risk, and again, the local authorities in this area typically know an awful lot about where their risks are, and they will generally be requiring this work to be done in advance of planning to ensure that those stability risks are taken care of. So slope stability, this is one that's far more site specific. So this is one we're working on at the moment. Again, the client was aware of it. So this is adjacent to the Maxfield Canal. That photograph doesn't show it terribly well, but the slope is in places close to a 1 in 1 degree angle. Now it is probably stable entirely because it's a very old slope and it's got 100-foot high trees all the way along. The trees themselves and their roots will tend to provide an awful lot of the stability. The developer has taken the wise decision to keep the plots well away from the crest of that slope. So the plots that are along this boundary here has kept them well away and given them slightly more generous gardens, so that when these are built, they won't pose a risk to the stability of that slope. We're currently doing detailed technical work to prove that that's the case, but that was accompanied by a very specific condition, which was condition 14 here that we are currently working to deal with. So again, that needs site-specific inspection, and you can see on the right, this is one that's been done previously. You can use computer models to determine the stability when you impose a load to the top of a slope. So that is very important. So sorry if that's a bit of a whistle stop, particularly through ground risk, which I appreciate is probably less commonly talked about than contamination, but is equally important. And as I said early on, the costs in terms of mitigating ground risk and ground stability risk can be more substantial than contamination. So within the whole development team, and I'd include the regulatory side on that, make sure that there is sufficient information at each stage, but also it is only commensurate with the risk, so that very detailed assessments aren't undertaken in advance of planning all of the time. Just make sure it's only undertaken when reasonably required. So that is a process of having good desk-based work done up front to identify the risks, and then where necessary, undertake intrusive investigation to actually assess those risks properly, and make sure that where there are ground risks, whether contamination or geotechnical ground stability risks, that the master plan is not fixed at too early a stage, so that the architect, the master planning, the client is involved and aware of the ground risks and can amend and develop the master plan as those are established, so that mine shafts can be avoided, high walls can be avoided, steep slopes, etc. And that's to make sure that the site can be developed in the most economical manner, and that once planning is granted, that all of the stakeholders are confident that that particular development outline can be delivered. And always use competent specialists as well, as a little plug at the end. There are plenty of competent specialists out there. Try to make sure that they have expertise both in stability and contamination risks, because you never know when you're looking at a site which type of risk is going to be prevalent, or as is often the case in the UK, it's actually both. So I appreciate we're now at 2 minutes to midday, so apologies for going right up to the limit. I think that's it, if anybody has any particular questions.
Yeah, thanks Richard for taking that over after the initial technical difficulties.
All
There's
right.
a couple of questions. One from Jan Farnham, and that is, is it deemed acceptable to locate private gardens over areas of land instability? Isn't it a safety issue?
A very good question. So typically, and as you saw on that open cast development, the back gardens are over the area of the high wall. So in theory, there can be settlement. It comes down to what is acceptable settlement in any given case. So for most structures, the tolerable settlement is about 25 millimeters in total, so 2.5 centimeters. Beyond that, the foundations become at risk and the building comes at risk. For a garden area, clearly you would allow a bit more settlement than that, but you still need to know what the total settlement is going to be and whether that's going to be unacceptable. So what I would say is, in a garden area, the loading is going to be far less because you're not sticking a structure over the top. And therefore the actual tolerable level of settlement might be slightly greater. So for a garden, if it does settle in a particular manner, maybe 100, 200 mil over a period of years, that might be acceptable, or it may not. So it will come down to, first of all, you need to know what is the predicted settlement for that use if it is a garden or landscaped area. And then is that going to be acceptable both to the developer and or to the various stakeholders, because the developer will also effectively need to be asking the question on behalf of their insurers. So is that risk effectively going to be acceptable to the insurers? So yeah, you're very right. Some aspects of ground instability, a garden wouldn't be suitable. If it's a risk of slope failure and a very steep slope giving way, then clearly that's not an acceptable risk even in a garden. If it's a small amount of settlement associated with historical fill and it's just going to settle in a total manner very slightly, that should be acceptable. So yeah, again, it just needs proper assessment.
Thanks. And one from Rowan Devlin, more of a statement really, and I think it ties into a question that I had. Thank you for the presentation. Formal discharge of planning conditions and appropriate enforcement of the planning permission is an essential element to the process, as we know. Often verification information needs chasing up from developers, sometimes after houses have been sold on to individual parties. And I just, in terms of trying to offset that risk, because you know, at the end of the day, that is something that the house owners are not going to be best pleased about, I guess. And so to tie that into the question that I had, it was, give me a moment, too many screens, unfortunately. In the Lay Valley example, presumably the resulting pollutants were found by the regulators after, you know, permission, after everything's been developed out. Would you anticipate that a thorough contaminated land focused SI would have highlighted the risk to CRESS prior to them developing the site? For example, would one type of lab testing not being undertaken hidden this £20 million of cost risk to the developer?
There's quite a few questions within that. That's a very good, very difficult question, of which I think that formed part of their legal defence, which wasn't successful. So the investigations were done in the mid-1980s, and the science and the regulations have moved on a great deal since then. The judge decided that based on the history of that factory, they should have known thoroughly that they basically remediated soil-bound bromide and mitigated the risk of that. It transforms in the environment and leaches as bromate. And any decent contamination specialist, even in the 1980s, should have been very familiar with that and understood that risk. And that was the view the judge took. So again, it comes back to competency. Ourselves as consultants, it's something that sometimes keeps me awake at night, because bringing it up to the present day, there's what's known as emerging contaminants. So you might, and something we're not really looking at the moment, that you might think of, so just wider pollution as an example, microplastics is something that is coming to the forefront. There's often considerations in our industry as to what is going to be the next asbestos. There's something called PFAS, which is present in an awful lot of materials and fabrics, which has gradually been banned. Phthalates, which is a plasticizer. There's all kinds of contaminants which are coming to the fore, which haven't been known historically, where you may have some defense over. But really, if it was a factory like that was, and you know they produced and use these chemicals, then your consultant should be obtaining a good list of what was used and what is actually posing risk to the environment, and highlighting that, whether it's specifically prohibited now or not. It's a difficult grey area. I'd say for that site in the past, it was quite obvious they were manufacturing that sole chemical for a very long period of time, and they should have really known about it. But looking ahead, we do try and do horizon scanning, but it is increasingly tricky. We see it in terms of discharge of planning conditions, referring to the gentleman's comment. Yeah, it's a very good one. We often undertake reviews of completed developments for investors and find that there are undischarged planning conditions, often from several years ago, and we try and do that chasing of, is that information available? Sometimes it's not, and we have to go and try on behalf of the stakeholders, obtain that information on their behalves. Quite commonly as well on housing developments, we'll be asked to go and verify that clean topsoil, turn up on site and find out that the residents have already moved in. And we're having to knock on the door and ask politely if we can go and sample their topsoil, which, if that then subsequently is determined not to be of sufficient quality, can lead to problems all around, having to knock down the fences and to take that topsoil off whilst the residents are in. It's something that some developers and house builders are incredibly good at managing, and others are, even nowadays, still very disorganized and are not great at obtaining all that information and providing that verification data. So yeah, that's a problem that hasn't gone away.
Thanks for that. I've had another comment from Stephanie Walden just about reminding us to take into account other impacts from underlying ground conditions and ground risks. For example, in areas such as Ripon, underlain by phreatic gypsum, it's not acceptable to use infiltration techniques for drainage of surface water, which again should be something that we're picking up, I would imagine, Richard.
Absolutely. Yes, I mean, just for background, I mean, I'm based in Manchester, so my area is much more Cheshire and the salt deposits, but it's the same there. Brine risk, salt, as you know, will dissolve with water. So the last thing the brine board is going to allow are soakaways, where you'll have a concentrated point source of fresh water, which can exacerbate or promote further ground subsidence. So yeah, it would be the same with the gypsum. So there can be wider issues, and yeah, your drainage strategy will need to take that into account.
Thanks. And Julie Allenton's left a comment, and I think it relates to a specific issue relating to ground risk. But I think, to be fair on time and such, I think we'll pick that up afterwards, and we'll get your contact details, Julie, and drop you an email. So thank you all for bearing with us. It's been a little bit of a hassle at the beginning, but the modern working from home process has obviously led us to that. I hope you found it useful, enjoyed it. Thanks, Sinead, for preparing, and Richard for taking over after those connecting issues, which I'm sure you're much best pleased about. I certainly took away a few more questions myself, which I'll be asking the guys after the event, and I've left their contact details in the chat box if you want to get in touch with us. If you can fill out the online event survey, which will automatically load after the webinar ends, it does end quite abruptly. This only takes 2 minutes to fill out and is very useful for the RTPI, and you can also give feedback on what you want more practical webinars on. You can also get in touch with us should you want any more topics or discuss this further. And the presentation will at least be available in video form on the RTPI YouTube channel and through Dad Simons. As usual, we have a full events calendar located on the RTPI webpage, but do please have a look if you haven't already. The next Yorkshire events, specifically, because that's who's delivering this for you. Kelham Island, a sustainable neighbourhood vision, and a planning system fit for the 21st century with RTPI CEO Victoria Hills. So thank you all for attending. Apologise for those issues, and yeah, I'd speak to you next time. Thank you very much.